Now, members, let us see how we use the Newton-Raphson method with this question. So these questions are going to be like that. They can tell you to use to get it. First of all, you can get a root, the initial root, using the graphical method or using the near interpretation, depending on what the question wants. Let us see this one. Show graphically that there is one root of this equation. Hence, use the Newton-Raphson formula twice to estimate the root of the equation. Our Newton-Raphson formula, this is the formula we applied in the first lesson. So what we do, we let f of x be that. We said you can use a two-pot graph method or you can use a single graph method that we saw in the previous lessons. So here we test using -1 x equal to 0. How do you know that this is going to be the range? You see that when you try to test it, when you put here 0, instead it's going to give you a negative. So it means one way are going to get a positive. So see, between 0 and I put here n2, this one will be positive. So it means that it's going to be between 0 and 2 also. That's why I tried to extend a little bit so that my graph looks nice. Okay, when you start substituting the values, here the values in decimal points we are putting, you should be able to plot them. So here I'm putting one decimal point, one decimal place, because I'm able to plot them on my graph. If you put 2 here, you won't be able to put 2 there, or 3. So that's why now I'm putting always one decimal place, because I can easily plot it on the graph. So now, when we put in here, we say we use this method, we only want to see, we only note the change in sign of f of x. You see, negative, negative, not change. Negative, negative, not change. Negative, positive. From a negative value to a positive value, there is a change in the sign of f of x. That means that there is a root between the corresponding values of x, values that gave us these two. So the corresponding values of x are 0.5 and then 1. So meaning that our root lies between 0.5 and then 1. So to put now this, I come to my graph like this. So I have put it already. I think this is very easy. Then you join this curve using a free hand like this. So that's how our curve is going to be. And this one you name it, and this is our f of x equaling 2x cubed plus 2x minus 2 equaling to 0. That function there, because all of this was equaling to 0. So that's our function that we are plotting there. So now after that, we come and we approximate our initial root. So that now, this root now is what we use in that formula, in our NRM, in our Newton-Raphson formula. So that now, if I'm to approximate, now this one is going to be the initial root. Initial root. Initial root. Let me call it x naught. You start to see this one is going to be close to 0.7. So that's what we call our initial root. Now it's that now in my formula for Newton-Raphson, I need f of xn and I need the derivative of that function. So first of all, let's start with our function. Our f of x was x cubed plus 2x minus 2. We needed this and we need its derivative. So when I differentiate this, I get 3x cubed plus 2. Now, these are now, we need to now to evaluate them at xn and xn. So when I put in here my xn, f of xn, where there is x, we are putting xn. So this one is that is going to give me xn cubed, then minus 3 minus 2. Then after that, I also come with this. I need prime of xn. So this will be 3x. This is squared, please, not when you differentiate. X is squared n, then plus 2. Plus 2. Putting in where it is xn, and then x, we put xn. That's now. Now after getting these values here, f of xn I did. Then you substitute them in your formula and then you try to simplify it. So now from here, substituting these two, my xn plus 1 is going to be xn minus the whole of this is now here. You open in brackets x cubed n plus 2xn minus 2, the whole over this one, which is 3x squared n plus 2. After that, you try as much as possible to simplify. So if you cross multiply there, if you cross multiply here, I'll be adding this times this. Okay, let me do it. Okay, I'll be adding xn into 3x squared n plus 2, then minus this one, which is x cubed n, the whole over now is 3x squared n plus 2. So now let us open brackets and see what we are going to be having. Xn plus 1 is going to be now, and try to simplify that, we get 3x cubed n plus this times this, then minus this minus over many, then minus, then plus 2, the whole of this over 3x squared n plus 2. Now from there, we simplify, and now this is going to be xn plus 1 equal to this, and this will give us 2x cubed n. Then this and this one, we will cancel this. Then it shall remain with only a positive 2. The whole over 3x squared n plus 2. So now that's the formula that we are going to use. Now, they told us that to 2 decimal places, meaning here we get our maximum error or the tolerance. So our maximum error, some people call this the tolerance, the error we can tolerate. Tolerance is going to be, say, it's 1 over 2 times 10 power negative n. But n is the number of decimal places. From here, it's the 1 to 2, the 1 to 2 decimal places, implying that our n is going to be 2. So this will be half times 10 power negative 2, which will give us 0.005. So this is our tolerance we are going to use. Now from here, our initial root is going to be x naught. So when n is equal to 0, from here you see we shall get x naught. X naught here, then here we shall get x1. Now there we shall substitute in our value. So note, if my n is equal to 0, I'll be having now x1 equal to 2x cubed naught plus 2 over 3x squared naught plus 2, which will be, now I know my x naught is the initial. Now they are telling us that using it twice, so we are going to use this method twice. Now my x naught, I know from here, you know that our x naught from the graph was 0.7. So we are substituting this into the formula directly. So 2 into 0.7 cubed, then plus 2, the whole over 3 into 0.7 squared, then plus 2. But I'm going to show you a simple method on how you can plot that number onto a graph. So, if you have your calculator, this is how you plot that number. You place it on the calculator so that you can easily plot the curve. So you want to place that function there. So you say it's going to be open brackets. You say now 2, then you need x. You need this x here. So you first press the shift, the alpha, then this. So that it's having cubed. You press cubed. Then it's there adding a 2, so plus 2. Then you cross the bracket. Then they are dividing with, you open bracket 3, you need x, then it's squared, then plus a 2. I think you see there. So after pressing that thing on a calculator, the whole of it, then you press this button, this button, then when you press it, now this one is, you are going to substitute in the values you want. The value you want, the first value is 0.7. Then you press equals. That is the answer that they will give you. Now we give this one to 3 decimal places because our answer is, we said if our answer is 3 decimal places, then these values will give them to 3. So pressing that will be 0.774. And you see that when you get a difference between this and this, you see that now my difference between x, you start with the difference between x1 and this x0, x1 minus x0 is equaling to, when you get this difference here, you see that you are going to get this minus this, you see that you are going to get 0.074, which is not less than 0.005. So you go for one more round, because even the question told you to use it twice. And remember, I was saying that always add always, I mean the error made the difference between the two previous roots, I mean the two consecutive roots should be less than the tolerance. But in this question, our tolerance is this. So now we come to when n is 2. When n is 1. When n is 1, we have now x1 plus 1, x2 equaling 2 here, 2x cubed 1 plus 2, the whole over 3x cubed 1 plus 2. Now we substitute our x1. Now our x1 from here is this. We substitute into this formula now. 274 cubed plus 2, the whole over 2 into square plus 2. And the answer you get there. Now after doing that, for you just come back here and you press cal. You press cal again. It will give you now which value of x you want to substitute. The value of x we are substituting is 0.774. Then you press equals. That's the value that it will be giving you. You round off to 3 decimal places. So this will be now 0.771. Now you come and see. So that now our x2 minus x1 will be, by the way you can stop it, because even the question told you 200 twice, you are using it twice. So this is the first time, this is the second time. But even think, is that when you get this 0.771 minus 0.774, so that we are getting modulus of it 0.003, which is less than 0.005. So it's that now the error you can tolerate is very small, less than this. So there, it's that now our x, now the value x2 will be 0.771, which will give it 2 decimal places. It will be 0.772 decimal places as the question wanted it to be 2 decimal places. So that's how we handle that. We are going to try another example, but please learn how to press these functions on the calculator for easier work. See you.